are going this route. Paul will give practical advice and show photos of the observatory and diagrams depicting how systems have come together to make things operate. Ladies and gentlemen, please welcome Paul Shulins.
Thank you very much. It's really a pleasure and honor to be here. I've been coming to Stellafane for a number of years, and it's a real treat to be able to get up here and share some of my personal experiences with you. Our hobby has undergone a number of amazing changes over the last couple of decades. Specifically with the advent of CCD imaging, we're able to do some amazing work as amateurs and make real contributions to science. Some of the images that some of the best astrophotographers are coming out with that are amateurs rival those of the pros only a decade or two ago. So it's really amazing what the technology has allowed us to do. I am a radio engineer by trade. I live north of Boston, and makes it difficult for me to do a lot of this fun stuff during the week because I have to get up and go to work. So I, about 10 years ago, got into remote imaging by purchasing a fiberglass dome and installing it very close to where my home was. And that opened up a whole realm of possibilities for me with the go-to mount and CCD imaging and the advent of the internet and all that kind of stuff. It allowed me to do some meaningful work during the week and while I was sleeping. So it was a way to get a lot of imaging and a lot of scientific work done potentially that I couldn't do before. So what I'm here to do is talk a little about how I've done it, what some of the pitfalls were, and just share some of my real-time, real-world experiences with you. So why do it? Why remote image? Well, some of the advantages are that obviously a permanent setup is going to save you a lot of time. I think most people understand that. If you have a mount that's permanently polar aligned and set up, you're ready to go, basically. It allows for imaging at times when inconvenient, as I already touched on, weeknights, times when you've got to work and do other things. You can automate the process. It also allows you to capture a lot of the targets that you're going after when they're optimally positioned. You want to go through as little of the atmosphere as you can. So you can plan these things so that your targets are captured when they're close to the meridian and going through the least amount of air. It allows a large amount of data to be captured for each target. Again, if you're automated, it makes it pretty easy for you to be able to run scripts on a repetitive basis. And what happens is when you get more and more data, you can add that data together and obtain a better signal-to-noise ratio and a better-looking image. So it's great for that. And you can also put your permanent observatory at a desirable location, which I'll talk about in the next couple of slides. Well, some of the disadvantages to doing it this way are obviously it can be more expensive. You've got construction costs, you've got the cost of the dome, you've got a connection cost with the internet or however you're getting your data back. It's risky if you locate the thing far away. You've got to have some kind of support mechanism to make sure that you can fix something if it goes wrong. And something, of course, will always go wrong. And you're at the mercy of the internet for control and monitoring unless you've got some other clever way of talking to your observatory. That's how I do it. I use the internet. And if your internet service provider goes down, you're basically blind and you can't see your observatory. So you've got to realize that those are some of the limitations. And of course, depending upon where you are, you need to be mindful of security. You get a lot of money tied up in your telescope and electronics and so forth. You want to make sure that you're comfortable with where it is at. Speaking of security, there are some considerations, some obvious considerations, and these are some of the things that I've implemented over the years, whether my observatory was close by or far away. Having a fence around the observatory can be a plus and a minus. The fence does tend to offer you some protection. On the other hand, depending upon your location, it can draw attention to the fact that your dome is there, and if you're in an area where there's not a lot of traffic, it might just be better for you to leave your dome without a fence, especially if the dome is fairly secure in itself. I put together a web camera with motion detect and all that kind of good stuff so that, there is some surveillance there. Not so much for security, although that's a big part of it, but just being able to tell what the environment is like. Is there snow on the ground? Is the sky clear? If anything else is going on, it just gives you a good picture of what's happening out there. Of course, I've alarmed it. I've got door contacts on it, and put together an insurance policy to cover the replacement cost. So some things to think about if you decide to think about going down this path. Well, it's not easy to do. You need a lot to make it happen, and I wanted to list out some of the hardware requirements that you've got to have. Obviously, you've got to protect it from the weather, so a shelter is necessary, whether it's a roll-off roof observatory or a dome or some other type of automated shelter. You've got to put something together. Whoops. Back. You need a mount that obviously is remote controllable, usually called a go-to mount, with a pier. CCD camera is a must if you're going to capture data or images. Remote control focuser, remote control rotator is very handy so that you're able to position, if you're using a guide scope or an internal guider chip, to position the orientation of the camera such that you can get a bright enough star on your chip to guide it. So the remote control rotator was kind of a must for me the way mine is set up. We touched on the web camera. That was mostly, I was talking about an outside web camera, but it's also important to have an inside webcam of some sort or a video camera so that you're able to see what's going on inside the dome. Obviously, to look at that, you've got to have lights, and you need to have lights white lights that you can put on to and remote control those lights for when you're not imaging. But to observe the telescope and the mount, especially when you're 2,000 to 3,000 miles away, is a very handy thing to do. On-site PC to run the observatory. Better to have two in case one fails, but obviously that's something that's needed. Non-interruptible power supply is an absolute must so that you get good, clean power to the whole system. Some people have thought about this, but I found it absolutely necessary to have a cloud sensor, especially if you're going to have imaging runs that are going on while you're not watching, while you're sleeping or while you're doing something else. If clouds roll in or precipitation happens, you want it to be able to take action and close up your observatory so that you don't get water from rain or snow or whatever on your sensitive equipment. So the cloud sensor is mandatory. Depending on your location, you might want to think about lightning suppression hardware. I had some problems with lightning at the newest location in Arizona, so that makes sense to put in some suppressors on the primary AC. Computer-controlled AC outlets. There are a number of manufacturers that make these kind of things that you can control by a web page over the internet. And let's say your computer locks up or you just need to reboot it. This is a convenient way to be able to do that without using your computer to reboot it. If your computer's locked up, you can't use it to control anything. So I found that absolutely necessary. Some of these computer-controlled AC power outlets are very inexpensive. You can spend $100 and get something that will control 8 outlets and go to a web page. So that works really well. HVAC and dehumidification and or heat, depending upon the environment and climate that your observatory is in. The most recent place, I've got it out in the desert. I need air conditioning because in the daytime, even though it's a white dome, the outside temperature can get above 105 degrees. And I run my computers all the time, so I want that to stay down at a reasonable level. I set the air conditioning for 88 and hope for the best. But when it was up here in New England, we needed dehumidification in the summer and also heat in the winter to make sure that the computer and the hard drive didn't get too cold. Dew removal, not an issue for me now, but when I was here, we did have some electric new heaters on the telescope. Flat fielding, depending upon what your preference is and what the aperture of your telescope is. Flat fielding is something that I've been successful in doing, sky flats, and there are some computer routines that allow you to point the telescope at the appropriate time to the parts of the sky where you can take flat field images. Or you can buy some flat field, or make some flat field light sources, and point the telescope by remote control at that flat field and take your images anytime. And finally, interior and exterior lighting. And I touched on the interior lighting and why that's necessary, but the exterior lighting is also a good thing to have at night if you want to just take a quick look at the exterior of the dome and make sure everything's closed up. So the original construction was done near where I live in Andover. This is a photo of the form being getting ready to be poured, and you can see inside the middle here we've got some conduits that were laid for the electrical power and communication back to a building that was on site here. The pier here is 48 inches above the ground and goes about 5 feet into the ground, and is isolated from, or will be isolated in this view from the concrete floor that will be the floor of the observatory, so the vibrations from the dome, people walking around in it, would not be transmitted to the pier and the telescope. So this was the completion of the dome. As I mentioned, it's technical innovations, 10-foot diameter dome, and it was finished in May of 2000, and I used it for about 10 years with pretty good success here in New England. I'm sorry you can't see this image too well. I didn't realize we have so much ambient light here, but this, I'll try and point out the pieces to you as best I can. This is the computer rack, and it's obviously shot with a wide-angle lens. This telescope is not bent as it appears to be, but this is the rack with the computer in it. In fact, there's 2 computers in there, and some relays and power control items and so forth. There's a toolbox here in the back. Obviously, the pier here. This is my telescope. It is a RCOS 10-inch Ritchie with a ST10 camera on the back. And this is the guide scope on the top here with a remote guide imager. These are some of the automation controls that came with the dome. These allow the dome to be rotated and the shutter to be operated by remote control by the computer. So this is the hardware with the power supply and the relays in it that allow the control of the dome. I talked a little bit before about the cloud sniffer. This is what the particular one I have looks like. It's made by Diffraction Limited in Canada, and it looks like a little cylinder here. And if any of you guys don't know how these things work, they measure the infrared temperature of the sky and deduce whether the sky is cloudy or clear based on the sky temperature. That information is fed back into the computer, and that's used to determine whether it's safe to image. And there's just a little better shot of the computer in the rack. There is some AC outlet power control here. For example, the focuser, the camera, and the rotator all plug into these boxes, which put out 110 volts, and they're controlled by a 12-volt input, which the computer supplies. Again, a little hard to see, but this is the web camera here that shoots a picture of the pier and the telescope. And these, I have about 10 of them at equal distances from each other around the dome that are white lights that illuminate the dome, the inside of the dome, so that when I need to look at it, I can see it with the camera. And there's just another picture of the entire setup on top of the pier. So, we get a lot of snow up here, especially this year. And I really got tired of dealing with it. Obviously, the shutter's not going to open in that condition. I don't mind so much going out and brushing off the snow, but what happens is as you all know, because most of us from around here, underneath the snow is ice. And the ice sometimes doesn't go away for weeks, even with the sun shining on it. Some of the best imaging weather we get is after these snowstorms. It clears out, we get the high pressure coming in, and it's just beautiful. But I can't open the dome because it's all iced out, even if I get the powdery snow off. So it started to get frustrating after a number of years. So I made some friends out west. And for business, I go out to the Las Vegas area every year, and was always interested in the climate out there, and hooked up with some friends. This particular guy is one of the guys who is organizing RTMC from year to year, and he runs hats. His name is Alan Guttmiller. We've become good friends over the last 10 or 15 years. This is a telescope he built. It's a 20-inch, and he has invited me out to do some imaging with him whenever I would travel out that way. And he's a real good mechanical guy, and put this thing together. I told him he's got to bring it up here one of these years, but a long way to travel. But he's got it on a trailer, permanently mounted on a trailer, and it's a real clever installation. I'm going to put up a link to his website on my website if you want to learn more about his rig here. But anyway, he recently purchased some land a couple hours east of the Las Vegas area for the purpose of doing remote imaging. And right now, he's got a little ranch house on the land, and he takes his trailer and his telescope out there when he wants to image, and he eventually is going to build some kind of shelter for this out there. But we got to talking, and I said, Alan, I'd really like to, do some imaging out in the west, and he was gracious enough to offer me the ability to move my facility out to his land at really no cost except for the utilities. So I couldn't say no to that. So there's a little place in the high desert, just on the western edge of the Grand Canyon called Wheatview. It's up at around 4,000 feet, and it's one of the darker places in the country, I think. The sea is very good out there. There's a little bit of light pollution, about 10 degrees above the western horizon from Las Vegas. Otherwise, it's pitch black. It's really ideal. And there's probably 330 days of cloudless sun every year. So it was just about ideal for what I want to do. Again, it's a little hard to see, but these are some of the steps I went through when putting it together. I made arrangements to pack up my stuff from Andover, Mass, and get it shipped out there. But prior to that, we put together a similar type pier and concrete. And these wires down here were for the electrical and the communication that went to his little ranch house that is located about 50 or 60 feet away from what you're looking at here. So these are some of the steps that we took to put the thing together. We put the carpet down first, and you can see some of the pieces here were ready to be reassembled, I should say. And this is a picture of us putting up the walls. And a picture of it half up, just half the dome. This is myself and Alan and his wife Shannon. And these are some of the final steps in getting the shelter together. Again, the same physical pieces that we had when it was here in New England. And there we go. It's a picture of a wide-angle shot of the environment that it's in. This right over here is the house, which is about 50 feet away from the dome, and that's where the electrical comes from. And so this is the new layout. It's a little bit just shifted around from what I had before, but very similar. The pier, the mountain instruments, MI250 mount, the telescope, the guide scope, toolbox, computer, electrical panel, and lights, and all that kind of stuff. Okay, I won't belabor this too much. I don't know how I'm doing on time.
You're fine.
Okay. This I needed to put together before. I'm sorry?
20-25 minutes.
Okay, all right. Well, maybe I will be late for a little bit. This picture depicts what I had to do, or what my plans were anyway, for putting the thing together in terms of electrical and computers. It's basically a schematic of how it goes. So I'll run through this real quick. Again, if you have any questions, we'll hopefully have a few minutes at the end. We'll go back to the slide. But basically, this is where the power comes in here. I've got a little circuit breaker panel with some lightning suppression on it, and that feeds a UPS. It's a trip-light 1500 watt UPS that smooths out the power. And then this goes to the digital logger device, which is that electric remote controlled outlet device, which does not depend on the computer for remote control. So that the computers are actually plugged into here. You can see Dome 1 and Dome 2 PC, as well as the relay switch and the LCD monitor. These are all plugged into this so that if they need to get rebooted, I can do it without regard to having to talk to the PCs. The PCs are sitting here on a KVM, so I have one screen and the ability to use one screen and keyboard and mouse for both computers. And again, the screen is only used while someone's out there at the observatory setting it up. But what I tried to do is I tried to wire it in so that either one of these two computers could control all the peripherals, and I could remotely switch that. So that if I had a problem and this PC died, I could use this device here to switch all my communication lines to all my peripherals from one computer to another. And it kind of worked out. It worked out pretty well. So that was done via this relay panel. And basically I'm using for most of my communication RS-232. So RS-232 can be done with 3 wires, transmit data, receive data, and ground. And those can be switched through a simple relay. And that's what I have here is a bank of relays controlled by this guy here so that I could swap all my peripherals from one to the other. With the exception of the CCD camera. The CCD camera is a USB device, and I've got a separate USB switch here that goes to the camera over here. And the USB AV switch can also be remotely controlled by either computer. This device here is an RS-232 receive device that gets data from the computer and allows me to turn on and off all these outlets here. It's kind of like the same thing as this, but this does depend on the computer for control. And the nice part about this is that because the computer can do the actions of turning on and off the AC power, all these accessories, you can automate that process. You can write a program or a script to do that. Whereas this is just completely manual control. This is more reliable because it doesn't require the computer. This gives you more flexibility. So some of the things that the computer does have control over is the mount, the focuser, the rotator, the power of the camera, the low voltage inside and outside lighting that I have, and the HVAC. I've got a small air conditioning unit there that keeps the interior dome at a decent temperature. Then we go back up here and you can see the digital dome works. That's that device that I showed at the beginning, one of the first slides I showed, which is the device that controls the actions of the dome, rotation, and shutter. This is the shutter over here, and the motors that control the rotation of the dome. And that all comes back to a serial port that goes to either one of these two computers, depending on which one is selected. Does that make sense? Am I losing anybody here? Does it kind of make sense? Okay. And then, as far as the computer part of it goes, we've got the internet here, which is a DSL telephone line that goes to a wireless router and a hub. And what happens is that is of course connected to the two computers, and it's connected to the camera, and it's connected to actually 3 cameras that I've got going out there. So that's what the internet stuff is showing. Oh boy. I was hoping this was going to show up a little better. I wanted to show off a program that a custom rope to control the electrical outlets in the dome, and actually, it does much more than do that, but it gives me a much better picture of what's going on environmentally. And it's really important, being so far away, knowing, getting a good sense of what the weather is like. Even, just knowing the temperature and the cloud cover really isn't enough. You might want to know whether it's too windy to open the dome, for example. So I'm trying to pull all this data together from weather stations and local sensors to show me a color-coded image. And this is a local custom program that I wrote that kind of pulls it all together at a glance, so I know whether it's a good night to open the dome and do some imaging. Some of the labels here are relative humidity, sky condition is clear, inside dome temperature, outside dome temperature, the difference between the two temperatures, peak wind gust over the last 24 hours. The current wind, you can't see it all here, but it's right up here, it shows you the wind speed. How many hours is it going to be until sunset? How many hours until astronomical twilight occurs? Those are all things that obviously are easy enough to find out, but if you're sitting 3 time zones away, it may not be intuitive, especially since that changes with the seasons. So I find it very helpful to be able to display on the screen that sunset's going to occur in 2.3 hours and astronomical twilight will be in 4.5 hours or whatever. So it gives me a much better picture of what's happening in terms of where the sun is at. Then we have a graph here for the last 24 hours, this being the current time, and this going back 24 hours, showing the sky temperature, and it's color-coded to show what the trend has been over the last 24 hours in terms of clouds. And the higher this graph goes, the worse the conditions. And then I've got different colors like red and yellow to show precipitation and very cloudy conditions. Down here we show the wind speed. I don't think you can really see it too well, but this is kind of green in here. And you go over to this area where it's red and yellow, showing that about 18 hours ago there was some higher winds. That so the trend has been for the winds to drop off. So it may be a good night for doing it. And down here we just have the inside and outside air temperature and the trend over the last 24 hours for that. The other part of this, and again, there's some red squares here, which you can't really see too well, but those show that there are not favorable conditions for imaging. You can see red there. These icons here show the status of those outlets that control the peripherals, control the power of the peripherals. So the mount, the CCD camera, the focuser, white lights, inside, outside, and the air conditioning, etc. Those are controlled and monitored through these group of rectangles, if you will. Then what I also do, you never be able to read this either, but I grab the weather forecast off of a local website out there and display it on my program here so that it says, tonight partly cloudy, becoming clear after midnight, winds variable at 5 or whatever. So I don't even have to go to a website to look for the weather, it just kind of shows up on my page here. So some of the things that I was concerned about at this new site were the internet, because it's in a remote location and it doesn't get serviced by a lot of different companies. There's not much competition. The internet is expensive and it's very slow. As I mentioned before, the time difference requires you to think about what you're doing because in the summertime I can't really start doing anything until midnight local time. High temperatures needed. High temperatures were found to be present out there, so I needed air conditioning. The electricity was a little more expensive than I thought it was going to be for air conditioning, so it's something I wasn't counting on. I needed more sensors for the park and the shutter closed. I wanted to have an alarm system let me know that if something went wrong, I wanted it to ring my cell phone or give me a text message saying, hey, your shutter's not closed. Something's going on there. And the dust level was a little higher than I expected, necessitating a visit up there every once in a while to clean off the optics and all the other equipment out there. These are some of the major software components that I'm using. I happen to be using, and there are a number of good ones out there, ACP, Observatory Control Program by Bob Denny, Maxim DL, RCOS TCC is the program that controls the rotator and focuser for the particular telescope I have. Clarity is the name of the software that displays the cloud sensor activity. Digital Domeworks is another ASCOM program that Technical Innovations made available for their dome. Of course, the ASCOM platform, which is free from the ASCOM site. My custom AC power control software. Dropbox. If you guys haven't heard of Dropbox and you're thinking about doing something like this, it's a free service for a limited amount of data, which allows you to synchronize automatically one computer's directory to another. It's really a fascinating service, and I've made good use of it for this purpose. And then the Norton Ghost software I use for backing up all the data on the computer. So these are some of the images that I've recently been able to obtain. Picture of the Whirlpool Galaxy. Can't even see that one. Came out good. The Eagle Nebula. This is the H-alpha picture. And again, there's some color in there, but because of the light conditions, 2403 doesn't look too great in this light. But my website is pshulins.com. There's more information about what I've done here. I'd like to thank Alan Duckmiller, who of course made this all possible by lending me his land. Bob Denny from ACP DC3 Dreams has been just fantastic in terms of support for his product. Steve Brady and Larry Weber, Focus Max program, which was pretty essential for this kind of work. Jerry Smith, who owns Technical Innovations, has been very supportive. And Dan Gray from SciTech, who is the guy who developed an alternative to the control system for the mount, has also been a key part of being able to make this reliable remotely. So with that, I'll kind of open it up to questions. Be happy to answer any questions. Yes, sir.
You mentioned about having somebody on site to help Murphy get out. Can you talk about that? You didn't mention it.
Yeah, absolutely. I would not do this if there wasn't anybody available on site to help me out. Alan lives a couple hours away in the Las Vegas area, so he wasn't a good candidate for that, although he could drive in an emergency. But he has a friend who lives maybe 5 minutes away that they can come out, and I have an arrangement with him. Luckily, I relocated this about a year and a half ago, and luckily we haven't had much need to call him out in an emergency. It's actually been pretty reliable. The issues that I've had, and I usually end up visiting 2 or 3 times a year, and the issues I have are mostly electronic and not mechanical at this point. So that works out well. Yes, sir.
Did you ever have any trouble with bats or birds nesting?
Not yet, although it hasn't been that long. Oh, I'm sorry. The question was, do I have any trouble with bats or birds nesting? And the answer is not yet. I have had some trouble, believe it or not, with a bird dropping on the cloud sensor. And when that happened, it just read cloudy. So I had to have my friend go out there and clear it off. But seriously, I was afraid to image. I didn't know what it was clear about. I looked at the camera, but that kind of did me in. So it took him about 30 seconds to get the bird seed off. Actually, I think it was a seed, not even a dropping. And because there's a little ledge on the thing, the wind wasn't pushing it off. But that's all it takes, And I had a feeling that was it, but I didn't know for sure until he went out there and looked at that.
Before you had to install remote light control. The camera, the housing, they come with a wiper and a little camera.
Oh, okay, the question is, the camera that I have to look at the dome, does it come with a wiper and an enclosure and all that? And the answer is no. I just have I do have an enclosure, but it doesn't have a wiper or anything like that. There's so little rain out there, and it's pointed down at an angle that it really isn't a problem at all. I thought, if anything, the temperature was going to be a problem, because it gets so hot in the middle of the summer. In the winter, the coldest it gets is the low 30s sometimes, so it's really pretty temperate. Yes, sir? Okay, I got some that I think you were talking about downloading images and download speed. Okay, the question is download speed. It's pretty slow because it's just a DSL connection, but that's where Dropbox has come in really well, because it automates the synchronization of directories between the remote observatory computer and my cloud, presence with Dropbox. And what happens is, while an image is downloading, it slows everything down, so the screen refreshes are not that good. So if you're trying to do something, it's a little bit sluggish, but it's good enough to control the telescope and see what's going on. But I've gotten to the point now where I wake up in the morning and a directory full of images is in the cloud, and I have a high-speed connection in my house in Massachusetts, and when I turn on my computer, within a matter of 2 or 3 minutes, it all gets synchronized back to my local hard drive, and I'm able to work on the images. Processing the images is the next real challenge. There are many great amateurs out there who I'm learning from and who do a super job. And it's just nice to have all the data. I capture all my dark frames and my flat fields and all that kind of stuff. And if it takes a little while to develop the right techniques to process the images, well, that's fine with me. Yes?
How much was the power usage? What was the peak?
The power usage for the observatory? It's all in the HVAC. The air conditioning is what eats the money. I'd say my average electric bill throughout the year, excluding summer, is probably $10 to $15 a month. So it's not bad. In the summertime, it gets up to be $40 or $50 a month because it's so hot and things running all the time. And they have the monsoon season out there, which runs pretty much July and August, part of June as well. And I'm thinking maybe in the future just shutting it down for the monsoon season where it's so hot, it's costing me all that money in electricity just to cool it. The question is, insulating the dome, is it feasible? Yes, it is feasible. I've thought of it, but I just haven't gone to that extreme. It is white, and I did put all the electronics on the north side of it, so it's not as bad as it could be. But yeah, it's never going to be tight. The dome part of it would be more difficult to insulate than the walls. Obviously, the walls would be pretty easy to insulate, but haven't taken that step. Yeah. I mean, I'm lucky it's up at 4,000 feet too. If it was down, at sea level or thereabouts, the temperature would be 10 to 15 degrees warmer in the summer. But having it up there at altitude does help a lot. It snows out there in the winter, but only a few times, and usually by noontime the snow is all melted, so it's a real treat. Don't ever have to worry about ice at all. I was out there in April this year, and it snowed while I was there. We had about 6 inches of snow in 3 hours, and the next day it was all gone. Got up to be the 50s and 60s, so the weather's much better. Yes?
I understand that 50 inch also on 50, the first large telescope from downtown Tucson in preparation for controlling public. Will those folks really help
The comment was there have been a lot of work done on controlling Hubble and a lot of experimentation from some of the large observatories like Kitt Peak and so forth. Did I take any cues from them? No, not really. That's in another league. My trade as a radio engineer helped a lot. I was able to, configure a lot of these electrical outlets and so forth. Quite honestly, talking with people on some of the forums, some other amateur astronomers, like on the DC3 Dreams ACP website, you see a lot of people doing this. That gave me a lot of clues and ideas. I will tell you one thing that I really didn't touch on here that I think is important to consider if you do want to go down this road, is the fact that the pointing on the telescope is absolutely critical. If you're not familiar with plate solving is the ability of the computer to match up a star pattern on your CCD image with a reference star pattern so you know exactly where the telescope is pointing. And that's absolutely critical for remote imaging. And if the telescope is off by just a little bit, you're not going to be able to plate solve, and you can't guarantee where the telescope is pointed. And that gets into problems if you're trying to get a guide star on a very small chip and all that kind of stuff. So I went after the SciTech controller because the SciTech controller had a homing function, and this allowed you to re-slew the mount to a reference point so that you knew exactly where the mount was pointing every time, and develop a very accurate model of the mount's performance. And that model could be applied to any slew that occurred so that you know exactly, you're pretty much guaranteed exactly where the mount is going to be pointed. A friend of mine up in Maine, his name is Paul Burke, is doing the same thing with a roll-off group observatory, and he's even taking it a step further, putting super high resolution encoders on his mountain instruments mount that almost allows you to image unguided indefinitely. These 500,000 ticks per revolution encoders are absolutely amazing. He's just started experimenting with these encoders over the last week or two, and it's really unbelievable the things that these encoders are doing now. But what I wanted to get at was the pointing of the mount is critical. And if you're choosing a mount for remote imaging, it's a good idea to choose a mount that can do some kind of homing to get back to a reference point. Yeah?
You have more details on your website, or these details on this?
Yes. You can go to the website, and it's got more details, and it's got my email address. So if you have anything in particular, I can help you out with. Be happy to do that. Yeah.
You mentioned that you had a box that you can control remotely to turn the computer on or off your cycle.
Yes.
How do you control that box?
Okay, good question. The box that I talked about that would control the computers, how do I control that box? That is, as I said, external to the computers. So the answer to your question is that box generates a little web page, and that web page is visible on the internet. And you have to poke a hole in your firewall with your router to make it visible. But once you do that, you can just go to that web page, and it's password protected. You get in, and it presents you with an option of all the outlets, and you just click on which ones you want to turn on and off. And it's very inexpensive. It's $100, I think, for the device. It's made by a company called Digital Loggers, and there's a number of them. Okay. Yeah.
What about dust?
What about dust? The dust level, believe it or not, has not been atrocious out there, even though it's the desert. I did take a lot of pains to try and seal up the cracks in the dome where the concrete meets the flange at the bottom. So that's all caulked up pretty good. But obviously dust still gets in. It's not airtight. And at nighttime when the dome's open and the wind's blowing, stuff gets in. Dust hasn't been a problem yet for any of the electronics. As far as the optics go, I do brush them off about only once a year. So it's not terrible. I don't like it, but it's part of the deal, part of doing business, but it's not stopping me from doing any meaningful work. Anybody else? Yeah.
Where did you start with that building
Question is, where did I start with the software to control everything? It comes from part of what I do for a day job. I work in the radio business and I control radio transmitters, and I write some custom software for that. It's a language much like BASIC. It's called Power Basic, and it's a compiled program, a program that compiles code. So I can, basically what I'm doing here is I'm spitting out some RS-232 signals that go to a device, one of the boxes you saw on there, that control relays. And those relays control electrical power outlets. Yeah?
Are you still using the MI250 mount and is it still Gemini go-to on that?
The question is, am I using the MI250 and is it still Gemini? The answer is yes, I'm still using the MI250. I think it's a wonderful mount. Unfortunately, they're not being made anymore, but Larry from Mountain Instruments is a great guy. He's still supporting the mount. The electronics, I have shifted from, I'm not using the Gemini anymore. That's why I mentioned the SciTech. Something that some people, Paul Burke and myself, are starting to do is to convert these mounts to be controlled by different controller. And this different controller, in my opinion, is better for this application because it has some abilities for homing and so forth. The Mountain Instrument, the Gemini controller has a volatile memory in it, and if that battery gets low, you lose your entire pointing and everything, and the game's over. You have to go out there and read fluid and all that stuff. I didn't want to have to get on an airplane and go out there, so this SciTech has been a great answer. SciTech's used in a number of commercial applications. I think plane wave telescopes uses their stuff, and I have nothing but good things to say about their hardware. Yeah. Okay, I think I got it all. What operating system did I use? Is that the question? What about rebooting? Oh, how often do I have to reboot? Okay, I'm running Windows XP, and I have to reboot the computers. It varies. I can go months without rebooting them, or if something gets locked up and messed up, I have to reboot it maybe twice in a night. It's very unpredictable. But that's why having that external box is key to be able to do that. Otherwise, I always have to go out there. Is it okay for time?
Yeah, we're doing good.
Okay. Thanks very much.
Thank you. We're going to get started with the next talk in just a couple of minutes.